Hey, you two, welcome to part three. I don't know, part one to about part four of Blind 75 Leetcode questions. Today we're going to be solving the minimum rotated sort array and then searching in the rotated sort array, so stick around. Okay, so let's start off with find minimum in rotated sorted array. Um, so this one's interesting, right? So suppose an array of length n is sorted in ascending or order. Orders rotated between 1 and n times. So between 1 and the length of the array. So assuming this sorted array 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7 if it was rotated 7 times. So what you can think about this is that 4 times, just move the last number over 4 times to the left. So in this case, if I wanted to rotate this 4 times, I go take 7, pop it to the very back. So that's 1, 6, 2, 3, and then 4, right? So then it should read as 4, 5, 6, 7, 0, 1, 2, 3. So notice that the rotating a sort array is blah, blah, blah. That just describes it. Given the sorted array, given the sorted array nums of unique elements, return the minimum element of the array. So in this case, 1 is the minimum, so we return 1. Explanations over here, and over here 0 is the minimum. So you can solve this in like the simplest way is to just iterate over each element of the array, so that's like n time. That's not bad, but it's pretty bad considering you can do this in log n time, I guess. So that's what Leetcode is asking us to do. So let me just draw this out a little bit about like the different cases. So let's say we have the 0, 1, 2, 3, 4, 5, 6, 7 case. So over here, let's say it's rotated maybe twice. So that would be 6, 7, and then 0, 1, 2, 3, 4, 5. Right? And this one is, and the next one would be rotated the other way, so quite a bit. So 3, 4, 5, 6, 7, 0, 1, 2. I'm just making each case, right? So a case where it's the minimum is on the left side of the array and minimum is on the right side of the array, and then a case where I guess where it's in the original order because it's rotated exactly the same amount of times. So how do we find the minimum, right? So we're going to be doing the same binary search sort of algorithm, but sort of a modified way for it. So we're trying to find the minimum. So let's say we're at the middle, right? This is a length of 3, 4, 5, 6, 7. What's this? 1, 2, 3, 4, 5, 6, 7, 8 or 7, because that's how you count from indices 0. So 7 divided by 2 is going to be, it's going to return us 3. So it's going to be 0, 1, 2, 3, right? So now we're going to compare. Is 1 greater than 5? If so, if 1 is greater than 5, that means the minimum is going to be on the right side of the array. So same case over here. So we're going to start from the middle and we're going to compare, is the middle greater than the right? If so, that means the minimum is going to be on the right side of the array. If not, it should be on the left. So in this case over here, 1 is not greater than 5, so that means it's on the left side of the array, and then we drill down into that. So let's sort of build this algorithm, right? So left, and left is equal to 0, and right is equal to length of nums minus 1, right? And then while, or Golang doesn't really have while, so you have to do for left is while left is less than right, right, we're going to find the middle. So we're going to say middle is equal to left plus right divided by 2. Let's use brackets because bedmass, right? So now what we're going to do is we're just going to say if the middle number, so nums at the middle is greater than so in this case, let's focus on this one over here. So if nums is greater than the right side, so nums at right, that means that the number exists within this portion here. So what we're going to do is we're going to move the left pointer to the middle point. So we're going to say left is equal to middle. Else, in this case, right is equal to middle. So over here, the right, we're going to bring the right over to the middle. So right is equal to middle minus 1. So in this case, we're going to know that 0 is not so let's say this one is a 0 here, right? So how do we do that? We bring that down to 7, 6, 5, 5, 5, 6, 7, and then 0, 1, 2, 3, right? So 0, 1, 2, 3. So this is our middle pointer here. So if middle is greater than right, which is not the case, that means it's going to be on the left side over here. So then we're just going to move the right pointer to the middle over here. So now while we do this, let's just let's just do this. And then at the very end, our left pointer, because it's always in sorting order, is going to be our answer. So then we just return, are we returning the number? Yeah, we're returning the number. So we're going to say nums at left over here. Let's run this code and see whether it's right. I know it's roughly around this, but I'm really bad at indices, so I really need to try this. Oh, else is missing an opening bracket. Time limit exceeded. Oh, it's probably because. So in this case, nums at middle is great. So in this case, nums at middle is greater than this. So that means it has to exist on this side over here. Sorry, on this side over here. We know that since this is the case, that means the middle exists somewhere in between. So if we pick this one, right, 0 is less than 3. So it's not going to evaluate over here. It's going to go over here. So we're just going to add middle plus 1 because of this case over here. So if you notice, this won't be it. Okay, that is the right answer. Let's submit and see what we get. Cool, and that's this over here. The reason why I did plus 1 is let's follow along really slowly here. So if this is our middle number over here, which is 6. Is 6 greater than 2? If 6 is greater than 2, then search the right side of the array. Since we know that 6 is greater than 2, 6 cannot be the highest number. If anything, the right side might be the highest number, so we can skip searching 6. We can bump that up. So that's why we do left is equal to middle plus 1. Whereas here, in when we do in this case, right, 0 is less than 3, so it doesn't evaluate over here because 0 is, it'll check this condition 0 is greater than 3, which is not the case. So then we have to move the right over, and we'll move the right over to this one because this might be the answer over here. So that's why we did that. Cool, and that's this one over here. Let's move on to the next one, search in rotated sorted array. This one is very similar. So the previous one we were searching for the minimum, and over here we're searching for a specific number in the array. There's an integer of array num sorted in ascending order with distinct values. Prior to being passed to the function, nums is possibly rotated at an unknown pivot index, such that the resulting array, blah, 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 blah. So essentially it's the same thing over here. So I'm just going to copy these examples over here. So we can kind of leverage the past code to help us with this one over here. This would probably, so what we're going to do is we're going to find the same thing. We're going to find the minimum number, because the minimum number is going to tell us where the pivot is. And once we know where the pivot is, we know which two parts of this array is sorted in ascending order. Once we know that, and once we know the target, we can search the specific section of the array in regular binary search. So that's all we have to do. We take the inverted sorted array, we find the pivot or the lowest point. That's going to be where the array breaks in two different arrays that are in ascending order, and then you pick each sub array based on where the answer might be, and then you search that one. So just for the sake of time, and also it's good to practice copy and pasting because you're going to do a lot of that in software development. First, we're going to find the pivot. The pivot is going to be on the left. The left is going to store our pivot. So what we're going to do is we're going to say pivot is equal to left, and then we're just going to reset this. Left is equal to 0. And right is equal to length of nums minus 1. Okay, so now we're going to do some checking, right? So let's say the target is equal to, let's say we're searching for 3 in this case, right? So we're going to see, here is the pivot over here. We are going to see if target is greater than or equal to the pivot value. So the pivot value is going to be nums at pivot, right? And less than, and target is less than or equal to, so less than or equal to 5, which is the last one over here. So we go nums at right side, right? So let's say the value is a 5, sort of like the edge case. So if we pick 5, well, is 5 greater than the pivot value, which is 0? Yes, it is. Is 5 less than the absolute right value, which is 5? It's less than or equal to, which is also true. So now we know where the pivot is. So now we can say the left side, we bring it over to the pivot. So left is equal to the pivot point. Otherwise, we bring the right over. So the right is equal to pivot minus 1, because we don't care, because we know it's not going to be here, it's going to be here. So it's pivot minus 1 and the left side. So once we know that, I mean, it's pretty easy, right? So I mean, you use your regular binary search. So we do for left is less than right. We're just going to check whether let's get our middle number first. So left plus right divided by 2, and then we do if, just do a simple check, if mid is equal to target. If so, then we just return mid, which is going to be the index. They care about where the index of this value is. So in this case, 0, the index is 0, 1, 2, 3, 4. So we return 4. Okay. So now we check. So if target, let's do this example here. So let's say the target is 3, right? Is target greater than the left side? So if target is greater than the left side, so nums at left, then we sort of bring the left pointer to the middle. Otherwise, if that's not the case, if target is left is less than, then we just do right is equal to mid. Now I know I mixed something up, and at the very end we just return left. I know I messed something up because I always mix up indexes because they confuse me a little bit. But just let me think about this. So if target, which is 3, is greater than the pivot, then we bring it over. We make that equal to, let's say the target is 4. Is 4 greater than the midpoint? Yes, it is. So then we bring that up to here. Actually, it's not middle, so right, we already checked middle over here, so we can add that +1. And the same thing with this one, right? We can just subtract that because we already checked middle over here, so we can subtract those. Let's run this and see what we get. Syntax error, obviously. Man, I always forget Golang. I always mix up the syntax between Golang and JavaScript, even though they aren't really similar. Cool. Input is 0 and we found 4. Let's submit this over here. Expected -1 because 3 doesn't exist. Okay, so if it doesn't exist, then we just return -1. And we can do something simple here where if nums at left is equal to target, if that is equal, then we just return left. Otherwise, we return -1. Oh, I'm a noob. I'm checking for the left over here. It needs to be mid. So if target is greater than mid, then we do that. Right? And that is the accepted answer for that. Let's run this. Cool, and that solves this question over here. I think I got lucky the first. Oh wait, it didn't even pass. I got lucky for a few test cases, but this is the correct answer. We're always checking for the mid and we're comparing it because the middle is where the pivot is after you find the sorted array. But that's for these two questions over here. They're sort of similar and you sort of leverage the same code from either. I hope you enjoyed this video. In the next one, we're gonna be solving the remaining two, which is threesome and containing with the most water, which will solve all the array questions for Leetcode Blind 75. I hope you enjoyed this video. If you did, please show your support in the comments and the like section, and I will see you in the next video. Peace.